Vector kinematics position. We'll be using unit vectors to determine the position of a particle. So in our example, the position of a particle as a function of time is given by this long equation. We have 5 meters per second multiplied by time plus 6 meters per second squared times time squared is our I value. 7 minus 3 meters per second cubed times t cubed gives us our j value. R shall be in meters, t in seconds. Take a minute to notice how when you multiply seconds times meters per second, it will give you meters, which is in agreement with your R units. T squared will give you seconds squared, which will cancel with the meters per second squared. Meters has no time unit, so it's a right. And here you have time cubed, so seconds cubed will cancel with the seconds cubed to give you meters. So, what is the particle's displacement between time 2 seconds and time 3 seconds? So we're finding the change between R2 and R1. So the first thing we need to do is plug in 2 for our t variables. So 5 times 2 seconds plus 6 meters per second squared times 2 squared gives us an I value of 34 meters. 7 meters minus 3 meters per second cubed times 2 cubed gives us a j value of negative 17 meters. Our next step is to find the R2 value, so we're plugging in 3 seconds for our t value. So 5 times 3 to give us 5 meters, plus 6 times 3 seconds squared, so we have a total value of 69 meters for I. For the j value, we have 7 meters minus 3 times 3 cubed to give us negative 74 meters j. Our next step is to find the difference between them. So we're finding delta R by subtracting R1 from R2. So using your I's and J's, you can just take the values R2 minus R1 for I. So 69 minus 34 gives us 35 meters I. So that's the x variable for this vector. The I variable, or excuse me, the j variable or y variable is negative 74, which comes from your R2 equation, minus your negative 17, which came from your R1 equation. Subtract those two numbers and you have, we're going to subtract 57. We could also say plus negative 57 for our j value. This tells us that x was displaced by 35 meters, y was displaced by negative 57 meters.